All right, so I'm going to be talking about this card that I developed called the Apple2Idiot card. So I'll be talking about the development of it, some of the issues I encountered, and some of the technical details about the card, what it can do. First, I'm going to just take you through a quick introduction of the card so that you have some context for the rest of the talk. So it basically, it just has this ESP32 on it. It's an expansion card that lets the Apple2 talk to the ESP32 microcontroller through dual port RAM. For people that don't know, the ESP32 is a 240 megahertz microcontroller that has Wi-Fi, Bluetooth, analog to digital converters, and some other goodies. Let's see, I'm just going to set a timer real quick. Okay, so just about me, this is the first Apple2 project that I've done. Mostly I don't know what I'm doing. And I definitely couldn't have done this if it wasn't for the Apple2 community. My background is in Macintosh 68K stuff. I just listed some of the things there in case anybody recognizes me from them. Proof that I don't know what I'm doing. Here's an example early on. Or actually, just recently I made this mistake again, but I had a variable called Wi-Fi connect equals 10. And as you can see, that gets turned into WFIC unnect equals 10, which took me quite a while to figure out. So I'm no expert with the Apple II, clearly. I was interested in doing this because I had this book that I got years ago and carried around with me called The Hardware Interfacing with Apple II Plus by John Uffenbeck. In particular here, it says, are you tired of game playing on an Apple computer? And the answer for me is always yes. Every time I load old games, I can't remember. I don't understand how I ever liked them in the first place, and maybe I didn't. Plus, this book promises to let you accomplish projects such as turning on a room light or your furnace or your air conditioner. And if that's not enough, you can display the exponential charging curve of voltage on a capacitor. And that's pretty exciting stuff. So I'd always wanted to do it, do some sort of Apple II hardware project because of this. So this project wasn't really to solve any problem. It was just for me to be able to goof around with stuff. The priorities were that I wanted to develop hardware. I wanted to make some custom PCB board now that it's very easy and inexpensive to do so. Another priority is I wanted it to be easy. I typically like to do things that are easy, not hard. There's a lot of people presenting things that were very difficult at this conference, and I think that's wonderful. That's not what I do. I wanted it to be hand solderable, so through hole components, low component count. And I was hoping the last priority was that it would do something neat, but that was the very bottom of the list. So the other thing that kind of got me started was that there's this Apple II breadboard adapter that I came across from Renee, and this seemed to be like a very good first step for me. I could do a PCB manufacturing of this, and I put it in my Apple II to get started. I didn't even have to do that. Somebody in the Apple II world just mailed me one for free when I started asking about it. That made things easy. So I was going to talk real quick just about how I got over the hump of understanding how the Apple II hardware, the expansion cards work. So this is a diagram from the book that kind of illuminated things for me. The stuff in yellow is the signals coming from the Apple II via the card edge. So you have the data bus, and here you have the A0, A1, A2, A3, the address bus. And so you can see there's not 16 lines. And so I think maybe I'd always sort of thought that things were interrupt driven, or that you had to have full access to the address bus, which is 16 lines plus 8 for the data bus. And it just sort of seemed overwhelming, but that's not how the Apple II works. You have right, so there's your address bus and your data bus. Then you have this one line for each card, the device select. There's also another line called the IO select, but which can do something similar. But you just have this one wire, and when it's low, you know your card is being talked to or listened to. And then this other one, which is a read-write line. So when this is low, the Apple II is writing data to the memory addresses that are mapped to your card. So in this situation here, for this little circuit to work, all you have to do is just poke whatever value you want to show up on the data bus to this address. Also, I think that this figure, just as an aside, I think this figure, I think the A0 through A3 are mislabeled in the original diagram. There's another figure in the book where they're the opposite way. But so what this does is it gives you just have to listen to these 4 lines, and it gives you 8 address spaces that you can listen to or write to. Well, in this case, just listen to the Apple II and see what it's saying to your card. So this made things very simple for me. And in this situation, there's a 7404 chip, a 7420 chip, 7427 chip, and this 74100 chip, TTL chips. And well, that just seemed like a nightmare for me. I don't want to have to solder that much. And that's too many chips that I don't have, but I have an ESP microcontroller and I know about that. So I thought, okay, I'll use this breadboard adapter. I'll put the ESP32 on it, and I'll just have it monitor this stuff, and that'll work. Great. But it doesn't work because the ESP32, even though it runs at 250 megahertz and the Apple II runs at 1 megahertz, the interrupt latency on the ESP32 is around 2 microseconds, which is way too long. So the ESP32 is looking for this dev select line to change so that it knows it's being talked to. And by the time it sees that and starts looking at the data on the data bus, the Apple II has moved on to other things. So I'm sorry to go back and forth, but okay. So how do we solve that? So I thought, well, the Apple II can clearly write to RAM. All I need to do is just have it write to some RAM, and then I'll have the ESP32 read from RAM. And luckily, there's this stuff called dual port RAM that I found. So this is the chip that I use. It's dual inline package through whole components. Basically, the way it works is you put it between the Apple II and the ESP32. The Apple II pokes to the data using the data bus and the address bus on its side. The ESP32 listens. It can respond right back, and you can basically send messages back and forth. So this has 2K of RAM, but you can't use all of that in the situation because if you use the IO select line, you have access to 256 bytes. So that's what you've got. Basically, you have sort of this memory, 256 bytes of memory to send messages back and forth between these things. So I guess there's a little bit of storytelling here. I got the chip. On the left, it's the wires connecting it to the Apple II. On the right is just me hard setting pieces of memory so I could see if the Apple II could read them. Then the next thing I did was I got that to work. Then I tried to get it connected to the ESP32. That didn't work great. Lots of problems figuring them out. It's always fun. And this is the final version of the working breadboard adapter and the first version of cards that I had made. Of course, they had that's populated. So these jumpers on this side were basically because I didn't have a lot of faith that it was going to work, and I wanted to have a lot of these lines broken out so that I could reconfigure it. The only problem it really had was that I messed up some of the address lines. I'd used too many of them, so I did a Labage wire and I got it working. And then I made a new set of cards like this. So these are basically pins that you can connect things to if you want to connect sensors to the ESP32 and just reconfigure a couple simple things with the card. So here's the schematic. In the middle, here's the dual port RAM. Here's the ESP32, and this is bit of the diagram is the card edge. So I think what I just mentioned kind of covers this, but that's the schematic. So the first thing now that I had the hardware working, I needed to get some software working. I had an Apple II with no disk drive, so every time I wrote a program, I had to take a picture of it. Here's one that basically would write to the RAM and then would read from the RAM and then double what was in the memory and write it back. And here's a little proof that it was working. So the next thing I did after that was because it's an ESP32 and it has Wi-Fi, I put a web server on the ESP32 so that I could write to and read from the ESP32 from the Apple II, but then I could also, just in a web browser, I could look and see what was in the memory. So I could write to it and look at it from the memory. And I think this actually has some potential as like a debugging tool for other projects. So like if I'm writing some more complicated Apple II software, I could just send debugging output to this card and look at it on a web browser. Okay, so then I wrote some Wi-Fi software. Here you can scan Wi-Fi, see the access points, choose the access point, connect to it by sending a password, and then show the IP address. Of course, that doesn't really let you do anything. Now you've just connected the ESP32 to Wi-Fi, but you can't do anything beyond that. So then I wrote a weather client. I wrote one version in BASIC and one version in C6 in C. And here you can set the country and the city and get the weather and show the weather. And this is just using a JSON API. And one of the things that's nice about the card is that right, all that JSON parsing can happen on the card. And then you just take the pieces of information that you're interested in and stick them on the dual port RAM, and the Apple2 can access them. Here it is. Here's the C version. Then I started doing a Slack client because I thought that would be cool. But then once I got the very simplest Slack client weren't running on Apple2, I decided that's actually really depressing and stopped that because nobody wants that. This is and again, I just want to remind people that I really don't know much about Apple2 programming. So all of these interfaces look terrible and the coding is bad. I'm learning all of this as I go. But this is a chess client, right? I would never really be able to write a chess program, but there's an API on the internet. So you can play a game of chess against the computer. It tells you if the moves are valid or not. It lets you know when you've won or lost. If you have a enhanced E, the opposite player's pieces are in lowercase, so you can actually tell what's going on. I have an unenhanced 2E, so it's very hard to play because you lose track of whose pieces are what in this interface. Here's just sort of some of the debugging output that comes from the ESP32 over serial, so you can see the JSON being parsed. So in the end, just kind of what is it? Well, the card is a very general purpose microcontroller expansion card, but it becomes a very specific purpose once you put firmware on it. So this is not like two other things that I've learned about is Ethernet and the FujiNet, right? Those kind of remain general purpose, whereas this doesn't. You sort of are stuck with what you put on it. But it can be used for web APIs. So I've used it for weather and chess, like a monster manual lookup using a D&D API. You could use it as a Plex controller. You could import Google Sheets to VisiCalc if you wanted. You can use it for debugging software. I wrote a ROT13 encryptor, which I understand is ridiculous, but basically you can offload encryption to it and then read the encrypted stuff back. You can use it, connect sensors to it, use it for MQTT and IOT type things, et cetera, right? It's got Bluetooth, which I haven't even explored. I did try to write like an NTP to ProDOS time driver, but that didn't go anywhere because I just didn't understand what was going on. So the pros and the cons. It's really easy and inexpensive to build at home, low chip count, right? You can solder it by hand. The card handles the hard stuff. I don't have access to Ethernet when I've looked into buying it. They haven't been available. And when I look at the code to write for it, it looks like a great thing, but I think this is easier to just do one dumb thing easy. It's definitely not good for doing lots of things. So yeah, I think that's basically it. I know there's a talk on the FujiNet coming up, which I think is really exciting, and probably definitely a more robust implementation of this. So they're definitely different things. And that's it. So the future, I'm at the moment trying to write I'm interested in multiplayer things. I had this idea that like at an event like KansasFest, if you had several computers with this thing, they could do some sort of ad hoc network where they discover each other. There's even an ESP protocol for doing this. And then you could have some sort of like messaging or chat type thing where it's just this ad hoc network. The other thing that I'm interested in is using like this. There's an API called Eigengrau's Town Generator that dynamically generates a town with characters and places, and then you can use like the D&D API to dynamically create monsters, and you could have this sort of like slasher style adventure game that's dynamically built. I think that's it. I think I've gone up to like my time. So
Great, thanks. There is a Discord channel.
I will go into the Discord and look at those things and answer them in text.
All right, great. Thanks so much.